All right, everyone, good afternoon. Did you have a nice lunch? Okay. We are making it. This is the last talk. Thanks for powering through this whole week. And now we're here. And it's a great honor for me to introduce our last guest lecturer, Dr. Alvin Zhou. Dr. Alvin Zhou is an assistant professor at the Harvard School of Journalism and Mass Communication at the University of Minnesota. And his research focuses on computational social science and strategic communication. Dr. Zhou earned his PhD from University of Pennsylvania Edinburgh School of Communication. And before that, he got his 2 MAs in statistics and strategic public relations from the University of South California. And he also obtained dual degrees in mechanical engineering and journalism from Tsinghua University. So today, Dr. Zhou is going to give us a talk about computational storytelling. I think this is a fascinating topic that can string together all the things that we have talked about in the past few weeks. So without further ado, let's put our hands together to welcome Dr. Zhou.
Thank you. This is Alvin, assistant professor at University of Minnesota. My talk is we are computational storyteller, forging synergy between question, data, and a method to create a compelling research design. And I'm going to talk about 3 studies. First one coming up in New Media Society. Is it touch screen? Oh, it is. Okay. At New Media Society with my co-authors, Tian Yang and Sandra Gonzalez-Peter. And the second paper is exploring PR topics and intercluster dynamics through computational modeling. In 2023, I think, JPR. And the third paper is forthcoming at CSCW24, lower quantity, high quality, where we audited the Twitter algorithms timeline regarding news content. And before that, just an introduction. I was an engineering student, but loved journalism. Then I went to UC Edinburgh, did my master in mass comm area. And during that time, 2015, 2017, that's where all the buzz started, doing computational studies, And I learned topic modeling at that time. And the advisor that I had at UC Edinburgh was like, oh, you have engineering background, you must be really good at coding. Although I learned mechanical engineering, which is totally different from CS or computer science, anything like that. But I took the challenge, learned something, learned R, how to code, and really liked it. And I applied for my PhD at more than 15 different institutions. I was like, I just want to do a PhD. And I ended up in Edinburgh, in the East. And the Wharton degree is just free because you can arrange your course structure to get enough credits to get a free master from Wharton. So I was like, why not, right? And after I graduated, I've been doing 2 years at Harvard School, affiliated with the School of Statistics, Data Science Institute, and running the lab for computational advertising. Okay, that's gonna talk about the first study. The puzzle of misinformation exposure to unreliable content in the United States is higher among the better informed. And the question the paper is trying to address is, we have a normative assumption about how people should, consume news online in the digital media area, which limits the misinformation exposure. And we need to seek news from ideologically diverse sources. For example, the first intuition, we need to read more news, right? A lot of people don't read news. There is percentage like 3% of all the information online is actually about hard news, about political news. This is the first normative assumption that everybody will agree, right? And the second one is you need to read more diverse news. if you read so much Fox News, you should probably read some morning shows, right, to counterbalance that. And recently, we have a new normative assumption that we should avoid misinformation, right? So these are the three normative assumptions that we have about the news consumption literature. And this paper is saying that once these two things are in place, the third one is really difficult to achieve. Okay, so between the three, you can only pick two. And which two to pick? That's the question that the paper wants to aim the reaction or the discussion about. So what we did is we used web browsing tracking panel data from Nielsen, tracking around 140 unique users in the US from January to December 2018. And this data is from Nielsen. It's a representative US population panel with different weights provided by Nielsen. And it's URL level granularity. So you will see people visited for 20 seconds on this date to www.newyorktimes.com/politics/something/something. So it's a URL level granularity. Okay. And we also have all the details about the seconds, so the time that is spent visiting each pages. And as well as all the demographics, attributes, gender, age, education, race, ethnicity, and income. And we also have the repeated observations. So we are observing one person for the whole year. Some of them stay only for like 10 months and they drop off, but we have repeated measurements for those people. So with that data, we have the first measure, which is the misinformation exposure. We combined all the, from Greenberg 2019, hopefully most of you have already read that paper from Science. And we expanded that list with purchase from the NewsGuard data set, where we cross-validated their original domain with our newer domain from NewsGuard to grade all those domains from 0 to 100. If it's lower than 60, it's considered an unreliable news domain. The second one is the reliable news exposure. So in contrast to misinformation exposure, it's reliable exposure. And we combined 5 different websites, 5 different articles published before us, actually 2015 Science, 2016 POQ, Greenberg, 2019 Science, Peterson, I think it's a Computer Science Proceedings, 2021, and Dantian's paper in 2020 in PNAS. And we combined all of them to 813 domains, where only 707 they are visited at least once by our panelists. So we have a measure of their exposure to misinformation. We also have a measure for their reliable news exposure. So we already are able to do a plot like this. It's the correlation, basically, right? Once you have more reliable news, you have more unreliable news, right? And the association is 0.59, which means it's positively correlated. And those plots, they are colored to count for the number of news pages that they visit. So you can see like a lot of people actually don't visit any unreliable content. Most of them are almost zero across the closer to the y-axis equal to 0, right? So this is the first 2 measures that we have. The third one is ideological scores of those news domains, which we will use to assess the diversity of their news diet. And we purchased the data set from Advante. It's a more and more used data set nowadays, assessing US news domains, where they sample all the articles on news domains websites and employs a panel of experts, most of them are journalists, to rate news articles ideological slant from negative 38.5 to positive 38.5. And this is basically a content-based, crowdsourced measure of their news content. And we also did a robustness check using the audience-based measure of news domain, which uses the selective exposure thesis, basically. If Fox News have a lot of those conservative audiences, then Fox News should also be considered a conservative news outlet. So we have two different measures yielding the same results. And I think this plot should be really familiar with you guys, right? Like on the left, there are Fox News. On the right, there are Fox News, Breitbart, RushLimbaugh.com. On the left, there's New York Times, BuzzFeed, dailypost.com. So these are all the domains that we're working with. And now we're going to the interesting part where we measure the diversity of news diets by the pairwise ideological distance between all the news pages visited by the panelists in each month. So consider if you only visit NewYorkTimes.com, like all of them are from New York Times. You are not traveling, right? You are just staying in one place. So the distance is 0, right? But if you visit New York Times, and then you go to Fox News, and then you go to, for example, in the middle, like Washington Post or Wall Street Journal. So you're traveling around, right? You eat the left, you eat the right, you eat the middle. So you're traveling around, which means when the measure is larger, you are consuming more ideologically diverse news sources. So we are using this pairwise ideological distance for all those news pages visited by each panelist for each month to measure how diverse their news diet is. Okay. And for the distribution of that measure, most people don't usually travel outside of their comfort zone, right? A lot of them are on the left-hand side where the average ideological distance is relatively low. But there are still some, variances. People visit different sites. There are diverse people there, right? And with that, we have the last set of demographics for gender, age, education, things like that. And we also extrapolated partisans' leaning using their observations. So people will have different news diets every month, and we use that news diet to average into their monthly partisan leanings, so they can change from month to month. And okay, so these are all the variables that we have. We have two different kinds of DV. Basic information exposure being the number of pages that they visited, and also the time that they spent on those pages. Then we have the number of news pages accessed, the reliable news accessed. And we have the diversity score, and we have the demographics. So we're just going to regress the DV on the 3 IVs using the panel ID, panelist ID and month as the random effect. And this is the result. So we can see that the most significant predictor is actually the number of news pages, which is if you are more interested in news, you're more likely to get exposed to misinformation, which is really intuitive, right? If you are really interested in news, you will seek out different kinds of news and you are likely to encounter misinformation. And that's actually a known fact, I think, among a lot of the misinformation researchers. And the second one is the ideological distance, which means if you are going to access different kinds of news websites, you are more likely to encounter misinformation. And we have the third one, the partisan score, means, if you're more conservative, you're more likely to encounter misinformation, which is also a known fact. So the second one is mostly the interesting part. And compared to previous literature, we also showed many more different demographics, variables, effects. I think most people know from the GAS 2021 is the age, right? So we also have age to be a significant predictor. We also showed the employment, female, different income, and there are some new findings here, but it's not the focus of our study. And this is a random effects model. Well, A more stringent test is about within person effect. So for the same person from month 1 to month 2, does that relationship still stand? So we can see that the ideological distance still positively predicts the misinformation exposure for the single person. So think of me, Alvin, right? This month I'm visiting these news. And next month I'm visiting another set of news. For the same person, if next month I'm going to access more diverse news sources, I'm still more likely to be exposed to misinformation. So I think of this table to be the more robust results to show that there's a positive correlation between the two. So this is the first paper. The question is that we have 3 different assumptions. And we're showing that those 3 assumptions cannot work at the same time. And for the policy to change or what kind of interventions that we need to implement in the society-wide, you probably have to pick 2 out of the 3, and which 2 to pick. That would be the question for policymakers, right? And this is a study, but I want to talk about a story. These are our co-authors. Yeah, our co-authors. Oh, wait, what? You, oh, okay. I'm gonna meet him very soon, so we're good buddies. So the story is this paper comes from starting from data. Okay. If you look at the acknowledgements, we thanked how many labs from Duncan was. It's good. So we got the data when Duncan joined UPenn, where we had that data from Nielsen. There are nonprofit media research lab, which regularly post some cover papers for those data sets access. So we got the access for the web panel data, which is the data that we basically used for the whole paper, other than the news score and the content. So when we get the data, was like, what's the kind of the question that we can ask? And Tian and I, at the time, it's like pandemic. So we're just talking about, even before we got the data, we are already thinking about the question about the diversity of news consumption versus the misinformation exposure. And we had some suspicion that it might be positively correlated, while Sandra actually first thought it would be a negative correlated. We had an early meeting about this project. And then we got data and was like, oh, this data is perfect to test that presumption, right? So we got the question and we brought the data to Sandra. It was like, oh, what's the method that we can do to assess the diversity of the news sources? And we, in the very beginning, we used cluster, average cluster coefficient from also a UPenn colleague, David, Linton, and Steggy. And they used that data, that method to assess the curiosity of one person, how they browse the web. And we ended up with a more intuitive measure, the one I just introduced about pairwise ideological distance. But it's also included as an appendix to the robustness chapter. Okay. So this is the instance where we got the data first. And then we think about what kind of questions the data are suitable for. And that question leads to some measures that we have to develop. So from data to question to methods. Okay, this is the first case. Second, I'm going to talk about exploring PR research topics and intercluster dynamics, where we started from something else. Okay, the paper wants to assess what topics do PR scholars study in general, and second, what clusters or what themes emerge from that literature, and the third is, do these clusters or themes intersect with each other? And the answer is, we identified 65 topics. We clustered them into 9 different subfields. If some of you know, crisis communication would be one of them. Employee communication would be one of them. If you're familiar with the field. And then these subfields do not talk to each other. The data what we have is a web scraping data from 2010 to 2020, covering the two top journals in PR fields, JPR and PR Review, around 1,000 papers from PR and 200 from JPR. It's around 7 million words. This is basically the data that we work with the whole time. Okay. The first method, I think most of you will think is really intuitive structure talk about, right? It's an unsupervised machine learning model to assess what kind of things that document is writing about. So we identified 65 topics such as Twitter, Facebook, paper wrote about those social media platforms. And we also have the relationship management, non-problem management, as well as image repair, situational crisis communication theory. So there are, different nouns and there are different theoretical frameworks as identified, labeled by the author team. And then it's the qualitative assessment based on different diverse source of expertise. So, like, I'm the only computational scholar out there. The second author is ethnography paper author, and third one is a quantitative experiments, structural equation modeling scholar, and the last one is a very famous field person who witnessed the whole field's development for the past 30 years. Okay. So you need to have a diverse representation from the field to label and to cluster those topics into each other. So we cluster them into digital media, in a sense, relationship management to strategic management. It's a big paradigm in PR. And those image repair, situational crisis communication theory will be considered crisis communication. So this is the first method that we use, where it gives us a table to show what kind of topics one paper write about and what kind of subfields once we cluster them that they are situated in, right? So the paper like, comment, share on Facebook, how each behavior differs from one another is detected to have most of it about digital media. And all the others like crisis global PR, rhetoric, it doesn't have anything to do with them, right? So this is the very basic methods that you can use to decide the target. I think some of you should be very familiar with already. Okay? The second method is where we consider each paper as a mix of those topics or a mix of those subfields. When you write about two different things, you are introducing each other, right? So if you write about gender, you write about race, these are two different topics. And you're doing an intersectional research, right? You're introducing the gender topic to the race topic. So if a paper have 4 different clusters, if we assume there are 4 different clusters from 10, 20, 30, 40%, you are introducing 0.3 multiplied by 0.4 for the introduction between clusters C and D. So we are actually seeing a network within that paper itself, right? So the paper is introducing different clusters to each other, introducing different topics to each other with different weights. So it's a weighted and fully connected network between the 9 different clusters. This is a kind of like a visual presentation of how the field looks, okay? So this is the method to where we showed how the field looks like. It's a very static description, right? A lot of people like all the computational work, they're all very descriptive, right? You're describing how the field looks. So we thought about how can we do it one step further. So we did simulation. This is basically the data table that we are working with. We have 1,293 articles. Each article falls into those clusters at different weights. So it's a 1, 2, 9, 3 by 9. It's a data table, right? Okay. And the simulation that we are doing has some constraints, right? Each row should add up to 100%, right? Because it's the percentage of each paper that falls into that cluster. The other constraint that we have, which this is the first one, for each cluster proportion add up to 100%. The row sum should not change, okay? The second one, since we are simulating what the field could be, we are thinking about the cluster itself, the column sum should be the same as well. So in the alternative universe, the most prominent cluster, for example, crisis communication, should still be the most prominent in that alternative universe. We are only simulating the connections between those subfields. Following me? So, hello, Kiran. So the question that we have is whether or not those clusters talk to each other, whether or not they are getting co-exposed to each other less and more, right? So in the alternative universe, we are only simulating the ties between different nodes. We are not changing the node itself. Is that okay? Let's move forward. You can ask me a question afterwards, okay? So this is where my engineering background comes in, okay? So when I was a student, we learned about biology, like how species coexist with each other. It's kind of like a network. Species A and species B can coexist, so their ties 1, and the other, if they cannot coexist, that's 0. And to do that simulation, you usually just pick 2 different cells and swap with each other. And this is the first thing I thought about. Okay, let's randomly pick I1, J1, and randomly pick I2, J2, and swap them. Right? It's my first intuition. And then I realized, oh, it doesn't work. Because these 2 values will be different. If you swap them, the row sum and the column sum won't be the same anymore, right? And another simulation, very common, is picking 4 and swapping them. But it still doesn't work. Because if you swap them diagonally, this one will come here, this one will come here, but the row sum will still be different, right? And then I dig into some of the literature, how to do those simulation. And one of them was like, why don't you find a delta, right? It's a random delta, which will be bigger than 0, but smaller than the least absolute of the 4 cells. So you pick 4 cells, find a random delta, introduce delta minus delta, plus delta, plus delta, minus delta, to introduce all the noises to the table. Does that make sense? And once you swap them, it's still row sum is the same, column sum is also the same. So you're simulating the connections between the nodes. You are still not simulating the nodes itself. Cluster 7's proportion literature is still the same once you add delta, once you minus delta. And each pair still adds up to 100%. Okay. All ideas. Yes. So we did 1,000 simulated worlds, right? So the alternative timeline, right? The Spider-Man and the alternative universe, I think, that movie, you remember? Right? So you're simulating 1,000 alternative timelines. Basically, what the field could have been or should have been if we do not actively move 2 fields apart or connect them together. Okay. And we use the 95% and 5% upper and the lower bound as the confidence interval for that connection between 2 nodes. And we simulated basically what the field's interconnections should have been or could have been if we do not forcibly move them apart. And this is a terrible table, but I don't know how to visualize it actually. We made the cells bold if the connection is higher than what was expected, and italic if it's lower than what will be expected. And what we see is for digital media and strategic management, the tide is stronger than would have been in an alternative universe, which means when we write about digital media, we always think about strategic management from that mindset. But we never thought about digital media and political studies to combine them together in PR scholarship. So this is the study, and we used 3 different methods, from structural topic modeling to a descriptive network analysis plus a simulation. And this is another story time. Where do we start from? Take any guess. The first paper is starting from data, right?
Something from
Methods?
The observation.
Okay, so we started actually from a question. So the 2 co-authors, these 2, they wrote a paper in 2021. They did an interview study, interviewed all the big names in PR, and they interviewed like 25, all the previous editors and people with like 10,000 citations, those big names. And though they lamented and suspected that many single topic or single class review articles omitted signals for those inter-topic development. So we have a lot of review studies being like, oh, well, we are reviewing social media studies in CMC, right? Or social media in gender. And it omits a lot of the signals where people write about 2 different articles or 2 different topics together. And also another case is that they realize there are silos within. PR is a very small field, but we don't know each other and we don't cite each other. It feels like the small field of PR is becoming more siloed and more fragmented in the field, where people don't know each other, don't cite each other, and don't know what people are working with. So they had a study published, and they want to do a follow-up study. And they realized they cannot do much of what the interviewees thought about, right? So they Zoom called me during the pandemic, actually. I was like, oh, we had this paper, have you read it? And I was like, yeah, I just read it, it's just published. And they were like, did you read the silos within discussion? And I read the silos within section, and they were like, can we actually identify the interactions between those topics? And I thought, okay, that sounds like structural topic modeling, if you're familiar with the method. And then you thought about, oh, how can I do interactions? That's how I thought about networking. And when they thought about silos within, which is kind of like the comparison between what we should do and what we end up with, right? So that's where the simulation comes from. So this is an instance where we started from a question to the method 1. We need to decompose articles into topics, which is the structure of topic modeling. And then the question of what kind of intersections or co-exposures those topics and subjects has. And from question to project 2, which is the networking. And for the silos within is what kind of things that we can do to simulate alternative timeline so that we can compare the actual world with the simulated world. From question to method 1, 2, 3. And once we have that framework to work with, I know that we need to scrape the data. So that's where you learn how to use Selenium, how to scrape those papers, and how to figure out if your university doesn't have access to the journal, which friend you should call, right? So in the follow-up studies, we actually don't have access to one journal, so we have to call somebody else, like, please run the script on your laptop to script those journals. Okay, so these are starting from questions. So the last paper is starting from methods. Okay, lower quantity, higher quality, auditing news content and user perceptions on Twitter, algorithmic versus chronological timelines and it's coming up in CSCW. With some friends, probably some of you have overlap with. Xinchun from Tsinghua, and now is a UPenn and Brook student. Stephanie one, and then I have both UPenn engineering. So the paper, what we're trying to do is do two types of auditing. There are two common recs of those sort of media feeds. One is the chronological, based on the time. If you publish earlier, then you're showing up the last, right? So when you scroll, when you refresh, the top content should be the newest content. That's chronological timeline. And there is also the For You, like the page that we saw on TikTok. It's algorithmic. It's based on how people engage with data and all your user interactions beforehand. And in the paper, we show once we track all those users' algorithmic and the chronological feeds, the algorithmic feed actually provides less but better news URLs for those new users. And those changing feeds did not move the needle for the user perceptions. Okay. Data and methods. This is the infrastructure we work with from tonight. We're going to talk about later, called Intervene. It has three components. The first one is a web app, where there's a web interface for participants, consent, onboarding, and also the service that we filled for each week. The second is a Chrome browser extension, which collects all the URLs and also the engagements in the viewport. So where if you click on the link, it will also register on our end. And also it implements the conditions on the web page. And third one is the analysis pipeline, where we use the Amazon Web Service to rehydrate the t.co, the shortened path, back to the original URL. If you know that on Twitter, like everything is shortened, right? So you have to rehydrate them, and some of them will disappear, so you have to rehydrate everything. This is a visual presentation. On the left-hand side is the web app, where participants click I agree and sign up for the study, and also fill up all the survey results. On the right-hand side is the Chrome extension, collecting the URL, collecting the engagement, and also implementing the convention. And on the cloud, we have the rehydration and the URL classification that we're going to talk about later. So we have 4 weeks. The first week, when the participants come in, they fill the one survey about demographics, what's your liberal, conservative, what kind of Twitter, what kind of web browser that you use, things like that. And then we went into 1 week of observation. We didn't do anything with their Chrome browser. We just observed their interactions and social media feeds during that observation week. And after the observation week, we did 1 survey about their perceived echo chamber, perceived news trust, perceived news credibility, all those traditional journalism, political communication survey items. And then we go into the first week of intervention. So we enforce one of the 2 conditions randomly, either for you or either chronological on the Twitter page. And that selection actually just disappeared. So you cannot actually change at all, right? So once you logged in, you're going to the chronological, and some users may find, oh, where's the For You button? Because we actually just removed them, okay? After 1 week, we observe their behavior, filled the survey 3, which is exactly the same as the survey 2, okay? And then going to the 3rd week, where we swap the condition. So if you are For You for the 2nd week, you are going to be the chronological for the 3rd week. And then afterwards, there was another survey, exactly the same wording again. So this is the participant management procedures, where we recruited from Horrific, who lived in the United States at least 18 years old, used Google Chrome, used TwitterX, and accessed TwitterX at least a few times a week. So it's actually a very small population that we're studying, but they are also the population that will get affected by those algorithms at the same time, right? So that's how we justify the sample what we have. We have 822 on board, and 243 completed at least 2 weeks, and 218 completed the whole 3-week studies. And we give them 25 cents for the screening survey and the 5 for each survey, so 20 maximum, and plus the screening survey, and also some, reserve the money to some people will reward you, things like that. So you'll just give them some money. It's like, and Tokyo and I actually have a paper coming out about all those procedures, because we also ran a study like this, like we recruited participants, and it's a lot of work. And the paper is called the user-centric behavioral tracking, and we listed some practical suggestions about how to do those studies and how to manage all the participant boards, how to do crisis communication, how to write templates if people complain about your study, and what kind of things that you should do. Okay. And the measurement system is we had an onboarding survey about all the demographics, ideology, age, education, and the URL annotation for the media bias, and also news reliability, similar to the first study I talked about. The third one is the between-week surveys, where we filled the perceived echo chamber. How much do you think your news on Twitter is similar to what you already believed in? So it's the perception of how much you are in the echo chamber. We also have another question about how much you think a typical Republican is in the echo chamber. How much you think a typical Democrat is in the echo chamber. So you're not only perceiving yourself, you're also perceiving others, okay? The second is media satisfaction. How much do you like your Twitter experience for the last week? Okay, simple as that. The third one, perceived news reliability and media trust. We actually didn't have that in the first draft. And then we added that for the final study because we realized we are logging all the media credibility of the URLs that they're exposed to, but maybe they perceive it differently, right? Even if they saw really good news, they might still think they are getting exposed to crappy news. So we add that question to the survey. The last one is the perception of the platform. Do you like Twitter? Do you think Twitter is favoring Democrats over Republicans? Do you think Twitter is favoring the Republicans over Democrats? And the data set that we have is around 1 million tweets and their engagement with that tweets for each week. And users only engaged around 1.89% of the tweets that they were exposed to. And 1.75 of them actually contained external news URLs. And all the analysis that we're going to talk about are conducted at the user level with user ID as random effects, and compare one participant's natural versus chronological versus algorithmic timeline and behavior. For the observation week, which is like simple comparison between the two, we saw that 1.6% of the tweets in the algorithmic timeline contained a news URL, while the chronological timeline have 7.5%. So this is like not a good, like very robust comparison, but it's a simple comparison that you can see that the chronological actually have more news URLs in users' timelines. And right-leaning users saw moderate amounts from the left-leaning news domains, while the left-leaning news saw very little from right-leaning news domains. Okay, now we go into the interventions. The algorithmic audits, where we saw the ideological congruence, we used a weighted congruence score if a user is extremely liberal, which is -3, and they are exposed to New York Times, which is also slightly liberal news domain, rated at -8.13, and that exposure is counted as -3 multiplied by -8.13 as 24.39, that instance, right? And we saw that it's more congruent in the chronological versus the algorithmic timeline. So on the chronological timeline, people are exposed to news that in their favor, right? And then second one is news extremity, where we use the mean absolute bias for those news domains that they are exposed to. For example, for New York Times, we take the absolute is 8.13. So we're measuring how extreme or how far from the middle their news exposure is on Twitter. And we also see that it's more extreme in the chronological compared to the algorithmic timeline. The third one is the news reliability, which is not significant, but once we show the visualization is more clear, that it's more reliable in the algorithmic compared to the chronological timeline. And the visualization looks like this. In the algorithmic timeline, lower congruence, lower extremity, higher reliability, not significant, but we don't have a lot of research to work with, so it might be a power problems. Now we look at the user perceptions. Users' exposure for the news event, we compare the 3 different timelines for each individual. Higher in chronological versus algorithmic, which is kind of in line with the visual that we just talked about. User engagement, there are more tweets and engagement in the algorithmic compared to chronological, which makes sense, right? Twitter wants to create a For You page so that you can engage with it. And there are also slightly more engagements with tweets with URLs in the chronological timeline. And user satisfaction, they hated us for enforcing that timeline sorting. They're like, oh, we don't like it. So observation is 3.38, and they went down for both weeks, and it's extremely significant. So as a visualization, the number of tweets in the viewport is higher for algorithmic tweets. Engaged is also higher in the algorithmic. Number of news tweets in the viewport is lower. The number of news of tweets engaged is not significant, but it's also probably the power issue. The last slide is actually the most important one, I think. The user perception of bias. We saw that the perception of bias associated is positively associated with their actual news bias. So when you see more liberal news, you actually perceive it to be, oh yeah, I think for the last week, I saw more liberal news. So people are actually aware, and thank God, right? Then their exposure to news bias did not change their perceptions on more higher level perceptions. For example, the average bias of all the news links available on Twitter, and whether the Twitter algorithm favors conservatives over liberal or liberals over conservatives. And user perception of credibility, we saw very significant effects, that the exposure to news of higher credibility actually leads to less perceived credibility. And we divided them into Democrats, liberal, different groups. It's all the same results. So when you are exposed to more credible news URLs, when you are answering the survey, people are like, oh, I don't think I'm seeing good news for this week. And this perception and behavior gap is something that we discussed in the discussion, but I think it's also worth more investigation about the gap between the perception and the actual behavior. The third one is user perception. As you can see, it could be a really complex interaction thing to do, but the interpretation is people report a typical Republican's timeline is less conservative than I thought when I were exposed to a lot of the conservative news. Well, a typical Democrat's timeline is more liberal than I thought. That's what users reported after according to their survey data. Storyline, the 4 of us, we started from the methods. Okay, so Denai graduated from Stanford CS and came into Penn as the HCI assistant professor, and they developed the intervening infrastructure for a study on their dissertation and also an advertising, targeted advertising. And they have a secondary appointment in communication. And integrated study. And so we thought about doing the audit related to news, right? So what platform to audit? That's the first question. What kind of things that they can track? And at that time, we already knew that my advisor, or all of you know, there's a big studies from Science Nature about auditing the algorithm of Facebook, right? So we know that one of the big platforms is already taken care of, and maybe we should do Twitter instead. That's where we ended up with Twitter, and we tweaked that infrastructure to capture all the news URLs in Twitter. And it's basically scraping all the time, right? Once you're scrolling, it's basically scraping all the HTML behind that Twitter account. Make the change to the extension prolific to the survey, and the topic is about algorithm audits. So we went from a method to the question about between the two different timelines that we can track. And to the data, where we have all the participants' engagement and exposure to the Twitter timelines across 3 weeks. And data, we also acquired the study. I already have that Fonte data set and NewsGuard, but we also redo all the ComScore audit annotation for all the news domains. So this is an instance where we started from methods, then to a question that we can answer with that kind of methodological framework, and then got the data to come up with a research design that makes sense. First study, starting from data. Second study, from a question, a qualitative study asking, and I helped them run that whole project. And the last one is starting from the method. What I'm trying to say in this talk is that instead of blindly applying the computational methods to social data, computational social science should forge synergy between question, data, and the method, and starting either with a question that you have, or a co-author have, or some invaluable data that you acquired for a lot of money, right? Or some innovative methodological framework. But in the end, you have to create a research design that tells a story from the beginning to the end. And you can start with data, you can start with a question, you can start with a framework, but it ended up should be a compelling story overall, okay? And I like the word forge here. In Chinese, it's called 锻造, means like you have to melt something and melt with something else, right? You can acquire data first, but once you find that data, you have to pick the question, pick the methods, and melt all of them and combine them and create something concrete in the end, right? So you have to melt them. It's not like 3 different parts. You have to melt them and create them together. Now, practical suggestions, according to me, because I have some discussion with Yang Tian, for example. He doesn't believe the social thing. So I'm writing an editorial, and this is kind of the thing I was thinking about mostly, about computational social science beyond data, and Tian is not on board with that. I think computational social science is more than computational methods. It's also more than social media, for sure. It's also more than big data. And the research design question, which is the so what question, is more important than the data or the method that you use. And the CSS study needs to tell a story and ask yourself if your story, which is reflected by your research design, is compelling or not. And then if you are starting from scratch, maybe start with a question first. And I was talking to people earlier. I also did a lot of study where I got the Twitter data and ran all of the analysis and pushed the data out to get a paper. But I think we are beyond that point as a field. And to think about what's the question that you want to ask, and then find the appropriate data and appropriate method to answer the question. And this is my talk. Thank you.